Right, so let's take a look at number 53. Here we've got a dart player throwing a dart horizontally at 12.4 meters per second. So therefore, all of its velocity is in the horizontal direction, 12.4 meters per second. So let's separate it, horizontal and vertical. Remember, that's usually the first thing we want to do after drawing our picture. So in the vertical direction, since all the speed is horizontal, we know our initial speed is going to be 0, and that horizontal speed will be 12.4 meters per second in the horizontal direction. Now we also know that the dart hits the ground 0.32 meters below the height from which it was thrown. So in other words, it free falls 0.32 meters. So we know that this distance here will be 0.32 meters. What we're trying to find is how far away the player is from the board. So we're trying to find the distance, or in other words, the range, the horizontal distance that the dart player threw the dart. So as we know, if we can find that horizontal distance if all we have is the velocity and the time. And we know that the horizontal and vertical components of velocity are linked through time. Another thing we know about vertical is there's going to be an acceleration involved, since it's free falling in that direction, of negative 9.8 meters per second squared. And we should also make this distance negative, this displacement negative, since it is going in the downward direction, 0.32 meters. So what we can find, we know our three equations. We have VF equals VI plus AT. We have VF squared equals VI squared plus 2A times displacement. We also know displacement equals VIT plus 1/2 AT squared. So let's go ahead and find our final velocity, because that will help us find the time. So we can use our equation VF equals VI plus AT. We know that VI is 0 plus negative 9.8. I'm sorry, we can't use that equation yet. What I meant to say is VF squared equals VI squared plus 2AD, where our initial velocity is 0 plus 2 times our negative 9.8 times our distance, which is negative 0.32, and we get 6.27 for VF squared, so we need to take the square root of that, and we get 2.50 for my final velocity. So that's my final velocity. That means that I can now use VF equals VI plus AT and get my time. So we know it's going to be negative at 2.50 because it's going downward. The initial was 0. The acceleration is negative 9.8. And we don't know the time. So let's take t equal to 2.5 divided by 9.8. And we're going to get 0.26 for the time it takes that dart to travel. Seems like a reasonable time for a dart to fly through the air. And so therefore now we have a time of that range, and we also know the speed it's going that range. So we can rearrange this to be d equals tv. So d equals my time, 0.26 seconds. I'm going to take that times, I have written here 1.24, but that should actually be 12.4 seconds. And once we multiply 0.26 by 12.4, we're going to end up with a distance of 3.2 meters, meaning he's standing about 3.2 meters away from the dartboard. So that's how you do number 53. The other one we want to look at is number 56. So this time we have a two-part problem involving an arrow being shot at an angle of 30 degrees above the horizontal. So here we have an angle of 30 degrees, and the velocity is 49 meters per second. It does hit the target. We want to know the maximum height the arrow will attain. So again, we're looking at vertical height. So what we want to find in part A is our vertical displacement, and for the horizontal here, what we want to know is if the target is at the same height from where it's shot, how far away is it? So in other words, again, we're looking for the range, just like in the last problem. So I'm just going to call that my horizontal displacement. So again, we know that displacement is equal to TV. That's the only equation we can use in the horizontal direction because it's not accelerating. We do again have those three equations we can use in the vertical because we do have our acceleration of negative 9.8 meters per second squared. So let's find our horizontal and vertical velocities to start off. Remember, the horizontal velocity does not change. So if we have 49 meters per second at 30 degrees, our y component of that velocity is going to be 49 sine 30. Our x component is going to be 49 cosine of 30. So 49 sine 30 is 24.5 for my initial vertical velocity, and that's positive because it's going upward. My 49 cosine 30 is going to give me 42 meters per second. So now again we are going to connect these horizontal and vertical components of the velocity through time, and in order to find time, it would be helpful to possibly divide this problem into two, because we don't necessarily know the final velocity, but we can call this our endpoint for now, our halfway point, because we know half the problems going up will be identical to the problem coming down since they're on the same level. So let's look at going up. Our final velocity is 0. So we can use our equation VF equals VI plus AT. That's going to give us 0 equals 24.5 plus negative 9.8 T. And if we solve that for T by dividing 24.5 by 9.8, we get 24.5 divided by 9.8. We should get 2.5 seconds. And if you have your signs right, that time should be positive. And that's remembered going up. So if going up is 2.5, the entire trip, the time is going to be 5.0, twice that time. So over here, we know now that the distance will be that time, 5.0, times the velocity, 42. So my range is 42 times 5, or 210 meters. And my vertical height we can use my distance formula, d equals vi t plus 1/2 at squared. We know my initial velocity was 24.5 in that direction. Remember, this is vertical, even though I'm writing it over here. Times that time going up, because all we care about is how far it went up. That's going to be our maximum height. So we're going to use the time going up for that. So times 2.5 plus 1/2 times negative 9.8 times 2.5 squared. So when we solve that, we're going to get 24.5 times 2.5 is 61.25 plus I get negative 12.25. So I end up with a max height of 49 meters. So that's how you would complete part A. Notice I did part B first, and then I went back and completed part A. Again, these are just a lot of missing pieces of the puzzle, so not necessarily important what order you find them in. Just know what you're talking about. Don't get your variables confused, and remember to connect horizontal component and vertical component through time.